Hello, Mario! Mario's cul-de-sac 16 Catchpits. I'm going to go to the earthworks one for this, where it shows the contours. Now, without doing a rigorous stormwater calculations, I have placed these catchpits in what I believe to be, likely positions. Obviously more detail, more calculation is needed, but we will definitely need some catchpits at the bottom of the SAG vertical curve, which is centered around 40, RL 40. So that's got to go in there. And so I've decided to put a double sump in there, and I searched through the double sump or double catch pit, and I searched through the Hamilton City Council manual for that, and there was some diagrams there but nothing very specific. So I had a look further at some of the pipe catalogues, and I found this one here from the Hines pipe catalogue, I think, or Humes or Hines pipe catalogue here, which shows a fairly typical sort of layout for a single sort of catch pit or sump. And just note the meter there. And I looked in, I think in the, I don't know, it hasn't got a double one here, but in the Hamilton one where the double sumps were like 400 apart, so I've allowed for that. So essentially I'm going to have a bit of a meter sort of transition in here is sort of what I've gone for. So it's a bit of a mash up of all of the things there, but obviously it gets across the idea that we do need catch pits. We need to consider water with our road design, and we have a thing to follow. So the main things that I've got out of here is it's around about 800, and I think I've gone with 450 and the 1070 radii that they've got here. Why they've chosen 1070 escapes me a little bit. It may be some sort of metric crossover from 10 foot or something like that. I'm not sure, but nonetheless 1070 it is. So let's just go back to our drawing here, and you can see that I've put the double sump there, and I've got the water flowing out of the cul-de-sac head. So I've decided that we'll put a single sump in there, and that'll sort of catch that water there. I've positioned it sort of there, but 100, 110 down to 40, so 70 meters there and possibly there. So it's sort of pretty even. Remember, catch water coming this way is coming around both of these as well. So one of the reasons for positioning and having the water tipping out of the cul-de-sac head is we don't have to bring the infrastructure for the sumps quite so far. But clearly, if we wanted to have a reticulation or an outlet for each lot, we possibly would have to bring reticulation up to a manhole here and have laterals out to these lots. But anyway, I know I've put a single sump in there. Now, one of the things I've done, used a lot of mirroring here because it's the same one side as the other. So once I've established the layout there, I just mirror it over to the other side and partly up the end here as well. So that's also partly why I chose to have them on the straights. It's probably a good idea to have them opposite each other because it means you can shorten the leads to the manhole, what have you. Now, drawing these can be a little bit tricky, especially with the S-shaped curve and that in there. So I've just got a little demonstration here on how to draw them. Just a couple of things to note. First of all, the grates, which I've shown as 800 by 425, I think it turns out, and I've shown them there with the slats in this direction rather than that direction, so that cyclists travelling along the road close to the curb can run across the the sump without getting their tyres caught in these here if they were around the other way. So first thing I did was just put in the two things, and I've actually I've got these grouped here at the moment. I'll just ungroup them. I've got these set up as a little block called grate, and then I just drew a line across here and offset that by the 100 mils that I've shown here. And so then what it remains to do is to get a reverse curve in through here with a radius of 107 or 1.07. So first thing I did is I just set up here and drew a line perpendicular up through there at 1.07 metres long, and then drew a circle 1.07 around that. So that's tangential there, and it'll come through there. Now it remains to find the centre point for this one here, which will be tangential at the same common tangent point there, but also tangential here. So what I did here was did an offset here from here to here, and that should be 1.07. So that's offset there. So we know that to get a right angle through there for that one there, we're going to have that radius, that's got to be 1.07. And then what I did here was I drew a circle 2.14, which is twice, because you're going to have 1.07 from here and then 1.07 from there, so that gives you the 2.04, and that comes through that point. So I'm able to draw a line through there. That should actually be up on there like that. I'm able to draw a line through there, and that is where the common tangent point will occur, and as you can see there, and I've actually drawn it parallel to the wrong one. I saw that there, so we'll just back the truck up a bit, or we can still have that there. It's this offset here. We should be offsetting from here, 1.07 from here, from that line to there. That's right. And then of course the 2.07 should be here, and the 1.07, and then this means our line, or the common tangent point on, should be coming through to there. Like so. Sometimes it's difficult to get these to show an intersection point there. The reason for that is of these heights here. So if I change that to 0 and change that there to 0, you'll see that if I now, I'll just delete that out of there, like that. If I now try and find this intersection with this, put that out there. Now if I try to bring that into there, I should quite easily get the intersection, the cross one, which is the one that tells me I'm dead on there. So that's across there, and now I can bring my circle here into position, like into this position here, like so. And that gives me my two curves which intersect with the common tangent point on that line. I also need a line through here, like so. Bring that back into there, the right angle, and then I can trim that. Do a trim on that line, and that line, and then so I can finish the trim. I can trim out that circle there, trim out that circle there, and that will give me my reverse curve there. We don't need that anymore. And then these lines here can all come out because they're no longer needed. That's no longer needed, and then obviously that's no longer needed now, and there I have my little completed curve round through there, which I can mirror off this line here, which will create the one up that end there. Can perhaps just quickly demonstrate that. So just select that arc there, and select that arc there, and then MI for mirror. Specify a point on the mirror line, which would be here and here. And do I want to erase the source object? No. And then you'll see, hopefully up the other end, yes, that there's the thing. And then of course I used those to trim out this line through the middle here, which, you know, hopefully intersects. So that's just a few little pointers on how to draw the little curved reverse curve and get that all to fit together. Hopefully that'll be helpful for you. So now back to our road detail, back to our earthworks cross section here, where we're showing all our catch pits and what have you in there. So that should enable you to give you a few pointers on putting the catch pit in. So remember how to draw the reverse curve there properly, and how to use the mirror to get both each ends of it the same and use those symmetry features. So all the best.